We're looking at the discriminant. This is from Pre-Cal 30S. The discriminant comes from the quadratic formula. It's actually what's inside the square root sign, b squared minus 4ac. The b, the a, and the c all come from the standard form formula of a quadratic, which is ax squared plus bx plus c equals to 0. Now for the discriminant, as far as determining the nature of the roots, there's 4 possible solutions. If the value comes out to a number that is greater than 0 and a perfect square, such as 4, 9, something that we can take the square root of and get a integer answer, then there are 2 rational roots for that type of equation. If the discriminant is greater than 0 but not a perfect square, such as a number like 17, then there are 2 irrational roots. If the discriminant is equal to 0, we have 1 real solution or root. And finally, if the discriminant is less than 0, there are no real solutions. So let's take a look at a question. We want to, and the question is worded usually like this, determine the nature of the roots by using the discriminant. So what we want to do is use the formula, find the solution to b squared minus 4ac as a number, and then go back and look at how many roots there are and what types. So first of all, I'm going to substitute into my equation. I'm going to write the equation up again just on the side so I can look at what I'm doing. And below, I'm going to take the b value, which is -2, square it, subtract it, subtract 4, times the a value, which is in front of x squared, which is 1, and the c value, which is 9. And I'm going to solve this like an order of operation question. -2 squared is 4. -4 times 1 times 9 would be -36. And so my solution comes out to a negative answer. The number is irrelevant. It's the sign here that's important when it's negative. And so my answer to the nature of the roots is that there are no real roots. And what that means is this is not a factorable question. And if I were to use the quadratic formula to factor it, I would get a negative sign showing up inside the radical sign. The second question, we have to be careful with this because before we can use the discriminant, we need to rewrite the equation in standard form. So when we move that -4 over to the other side, it becomes +4, and that becomes a big part of our answer. So I'm going to take 4, the b value, from the x, coefficient on the x, minus 4 times a, which is 1, times c, which is +4, and see what I get for this. Here I've got 16 on the left, 16 on the right, and 16 subtract 16 is 0. So the answer to this would be 1 real root. And finally, our last one, -3 squared minus 4 times a, which is 1, times c, which is 2. I get 9, subtract 8. That is equal to 1. And 1 is a perfect square. So in this case, our answer is 2 rational roots.